When we're drawing a sample, that is, when we're trying to make a statistic, we're trying to get something that best represents the nuance and intricacies of the population and best approximates the parameter as we can while being aware of the fact that we are never going to take in all of the information possible. The picture that we have there is never going to be complete. It's never going to be perfect. It's never going to have everything. And there's a real artistry to making a representation that doesn't have all of the information but still captures the spirit and may even do something better in some ways, especially in the fact of the amount of effort that goes into it. But we do have to be aware of the fact that it will never be everything. It'll never be an exact duplicate. It will at best be a clean picture that shows us what we want to be looking for without having to go to all of the effort to get every single thing. That is to say, we want to get a representative sample. We want to get one that effectively characterizes the behavior of the entire population, and that's not actually an easy thing to do. There's no guaranteed best way to make sure that you get everything from a population perfectly without actually getting everything. And in fact, that doesn't happen in practice. You can only hope to get some of it some of the time. And usually what we want to be able to make this as close as we can get is an amount of randomness. If things are perfectly random in terms of how we draw our sample, everything in the population is equally likely, then that makes our chances the best they can be. But at the same time, random sampling isn't a thing that's very easy to organize in practice. So often we have to fall back on some other structures, some other ideas that we can work with here, where in a more developed stats class we'd get more notation here. I'm going to hint at some bits and pieces of it with our next example, but, well, we're not going to focus too much on that for now. So, like I said, let's get that example to see what sort of things we'd be looking at, what sort of considerations we'd have to take in to try and make our sample representative. For this, which of the following would be the best way to select a random sample to find out how the city's citizens feel about casino gambling? Where we can randomly survey people who live in the oceanfront condominiums in the city. We can survey the first 200 people whose names appear in the city's telephone directory. Or we can randomly select neighborhoods in the city and then randomly survey people within the selected neighborhoods. So for that first case, just to get some idea of what's going on there, this is actually close to something that we would consider a cluster sample in another class, where a cluster sample is one in which we split our population into groups and then select groups. So in this case, we'd be splitting it off into the groups of location and type of housing and selecting perhaps entire buildings. And this would be one way to look at it, but the problem here is we can understand generally, unless you're living in a complete hovel, being on the beach is more expensive. And so, if we surveyed only people with beachfront property, well, the sample wouldn't be representative because we'd end up only hearing from people who have, say, money to be able to gamble. Generally, the people who live on the beaches, if they actually live there, tend to be wealthy retirees with lots of money and lots of time who tend to also like gambling. Well, tend to, it's an assumption, but the point is you wouldn't be getting a lot of people if you just went there. You'd be getting a great sample of the wealthy people, but there's a lot of other people who exist, despite what some may hope. Anyway, that first one, not particularly representative because you are focusing too much down onto a particular, let's say, class. Then for the second, what we would be looking at there is, well, maybe representative, but this is what's called a convenience sample in that case, where what we're doing is taking the group that is the easiest to get access to, and yeah, maybe the people from A. Aronson to B. Bennett are a surprisingly diverse group, but we didn't draw them based on their diversity, we drew them based on their ease of access, based on our laziness. So there's a chance that that's represented, and I'd say the chance might be even better than this, depending on some weirdness with demographics in the region, but more likely it's not representative. Or perhaps to be more fair about it, can't talk and spell at the same time. If it is representative, that would be a matter of blind luck rather than good design. So finally, for our third case, where we're looking at selecting neighborhoods at random, again, it's getting that randomness. It might be something like going in the phone book and looking at some numbers there, or looking at street numbers. It's hard to say exactly how that would end up being random, but we're assuming for the sake of nicety that it is, and then we're assuming for the sake of nicety that we're actually picking people randomly in there. Well, this would be an example, or at least close to one, of a thing called a stratified survey, where you're breaking people down into neighborhoods, strata, and then collecting from each strata to get your group, to get your sample. And this, depending on how we are working with this sort of situation, depending on how we are making our selection here, would probably stand our best chance of being representative. Again, there's no real guarantee of the sample being particularly good or representative, but this is probably our best hope, because we are taking random groups from random groups, I guess you could say. I should have picked a different word first, but you get the idea. That in our first case, we were too focused on one particular lifestyle. In our second case, we left it up to chance, not in the way that we want to. And then in the third case, we, as best we could, applied some randomness, and when you can apply randomness, the chances are better that you're going to get a meaningfully representative group of things, in this case people, from whatever population you're studying. So, now that we have some idea of what it is we look at, how we might look at it, how we might draw our pictures, as it were, let's, well, get into drawing pictures. But first, we have to get into drawing tables, so we'll look at things called frequency distributions to be able to better represent what our data looks like after we've collected it.